Let's put these in order of strongest acid to weakest acid. To do so, I'm going to want to convert them each into their conjugate bases, because I always want to ask these questions of myself about bases, and not about the basicities of these species, but about the basicities of their conjugate bases. So let's start here, and the conjugate base of this species. First, we realize that this is the most acidic proton, and you need to go through your hierarchy to decide that in the first place, but that's the decision. So this is our conjugate base. It has a resonance structure, so let's get that out of the way right away. So let's tuck that up here where it belongs, and do the same thing for each of these. So before I move on, this is the most acidic proton here, this is the most acidic proton here, this is the most acidic proton here, and this is the most acidic proton here. So now I've converted each of these to their resonance, or to their conjugate bases, and I've included any resonance structures that might be available that involve the electron pair in question. So now let's consider the atoms that bear the charge. So over here on this one, I've got nitrogen and a carbon, just nitrogen here. I've got oxygen and sulfur here, oxygen and oxygen here, and nitrogen and oxygen here. So I've got a nitrogen set and an oxygen set, but within the oxygen set I have a sulfur. Sulfur is larger than oxygen, so this is going to be the most stable conjugate base of all of the conjugate bases. The most stable conjugate base is the weakest conjugate base. It comes from the strongest acid. So this is my strongest acid. Now, oxygen is more electronegative than nitrogen, so my next strongest acid is going to come from my next weakest conjugate base, which is one of these. It has oxygen. So in this case, charge is shared between oxygen and nitrogen, and in this case, two oxygens. Oxygen's more electronegative than nitrogen, so this is going to be my next most stable or weakest conjugate base. It comes from the second most acidic acid. So this is my last one with oxygen, and oxygen is more electronegative than nitrogen, so this is my next most stable conjugate base, and therefore this is my next most acidic species. Both of these have a charge on nitrogen, but this one is resonance stabilized. So this is my next most stable conjugate base, and this is my next most acidic species. So this is last. So let's go over the reasons again. 1 versus 2. Well, the charge on the conjugate base is more stable on the large sulfur. So what about 2 versus 3? Well, the charge on the conjugate base is more stable on oxygen versus nitrogen. This is about electronegativity. What about 3 versus 4? Well, the difference here is the electronegativity on oxygen versus electronegativity on nitrogen. Both of them have charge on nitrogen, so it's oxygen versus carbon, which is a bigger difference than oxygen versus nitrogen. So in 3 versus 4, the conjugate base charge is more stabilized on oxygen versus carbon. This is an electronegativity effect. So what about 4 versus 5? Well, for number 4, the conjugate base is resonance stabilized. Not so for 5. So now we have an order and a reason for each numerically adjacent pair in our order.